Hi everyone, my name is John Kim. I'm going to be going over some information with you for systems of linear equations with three variables. It's linear equations, and you're going to have three variables such as x, comma, y, comma, z. So let's get started with a problem. Number 21. It's one of those questions where you can do it many different ways, but we're going to do it the traditional way. You have 4x plus y minus 3z is equal to 11. You have 2x minus 3y plus 2z is equal to 9. And you have x plus y plus z is equal to negative 3. I'm going to try to solve this the traditional way and with also the TI-89. I don't know if you can see this or not, but yeah, 99999. Hopefully you can see a little bit better. But anyways, I'm going to give you the inputs for those. First of all, I'm going to try to give it to you in a cookie cutter approach. I'm going to label these equation 1, 2, 3. I learned something about 4 or 5 years ago from a gentleman by the name of Mr. Pakula from Ventura High School. Rather a very good mathematician, teacher that is, and wanted to go over some information with you regarding Mr. Pakula. He said, first thing you want to do when you're given three equations with three unknowns, it's going to be one of those harder problems that you get, is you want to try to eliminate one of the variables. So here's step 1. Find the variable to eliminate. Well, you have 4x, 2x, y, negative 3y, y here, 3z, 2z, and plus z. This is probably going to be a little bit hard to get rid of, so we're probably going to get rid of the y's here. Step 1. Box it, he said. He said box the y, because that's the variable we're going to try to eliminate. So using equation 1 and equation 3, that's the easiest way to eliminate. I'm going to multiply equation 3 by negative 1. So, sorry, equation 3. So let's rewrite it. 4x plus y minus 3z is equal to 11. That's your first equation. Now I'm going to multiply equation 3 by negative 1. Negative x minus y, minus z is equal to positive 3. There we go. We eliminated the y. That's called the linear combination method. So you have 3x, and then, is this a minus right here? Yes, it is. So negative 3z minus z is minus 4z. When I add them up, that becomes 14. I'm going to call this equation A. We used equation 1 and equation 3. What I'm going to do is also use like equation 1 and 2. Since I used equation 1 and 3, I can no longer use those. I have to use either 1 and 3, 1 and 2, or 2 and 3. Did I say 1 and 3? Maybe. Anyways, let's get started. Probably going to use this one right here, or I can use this one, 2 and 3, or 1 and 2. It doesn't really matter. I'm going to multiply equation 1 by 3. So 3 times 4x plus y minus 3z is equal to 11. And then that becomes 12x plus 3y minus 9z is equal to 33. And the second equation, that's equation 1. 2x minus 3y plus 2z is equal to 9. And I'm just going to add those up. You get 14x minus 7z is equal to 33 plus 9 is 42. I'm going to call this equation B now. That way you have your equation 1, 2, 3, and then you have your AB. So what do we do from here? I have eliminate. Oh, I have two equations with two unknowns. I should be able to solve this. It's a little bit tricky. So do I want to get rid of my x's or my z's? Interesting. I have to multiply both equations by something to get rid of something. I'm going to multiply this. Since this is a big number, I like to use my z's, get rid of that. Multiply this by 4. Multiply this by 7. Negative 7, that is. So let's rewrite our equation. I'm going to highlight this just to make sure. And then negative 21x plus 28z is equal to 7 times 14. That's 28, 98. Negative. Now in the second equation, multiply this by 4. 4 times 4 is 56. Minus 28z is equal to 42 times 4 is 168. And so you end up with a very big number. I hate working with big numbers, but it's okay. 56 minus 21 is going to be 35x. These cancel. 168 minus 98 is going to be 70. Divided by x, I get x is equal to 2. Phew. If you don't get a really nice round number like 2 or something like that, you're going to have a problem, because if the answer is something like 35 over 7, etc., or 8 over 9, you're going to have a problem. So make sure you get a nice wholesome number. Thank God you're in high school for now. So anyways, we are going to do the second equation now. Here it is. We can either plug into equation A or equation B now. Plug in. I like this equation. It's a little bit easier than this one to work with. So 3 times equation A, 2 minus 4 times C is equal to positive 14. 6 minus 4z is equal to 14. Subtract 6 to both sides. Minus 4z is equal to 6 minus 14 is equal to 8. And z happens to be negative 2. So you have your first part, x is equal to 2, c is equal to negative 2. We're going to plug into one of the equations at the very beginning, either 1, 2, or 3. You can choose whichever one you want. Let's use this one, equation 3, because it's the easiest to work with. So x is 2. 2 plus y plus z was negative 2 is equal to negative 3. These cancel. Y must equal negative 3. So our solution set is 2, negative 3, and negative 2. We can check our work on this one by plugging into either equation 1 or equation 2. It really doesn't matter which one you choose, but it's easier to choose one of the easier ones, such as equation 1. I'm going to put my finger right on top of here so that I don't cheat myself. So using equation 1, I get 4 times x, which is 2, right over here, plus negative 3 minus 3 times negative 2 equals what? Question mark. 4 times 2 is 8, minus 3 plus 6. 8 minus 3 is 5, 5 plus 6 is 11. Woohoo! We got it just right. So this one worked out. We checked our work, and there you have it. I'm going to show you a little bit about this